Everyone, this is Kalia from Marcus Evans. Thank you so much for joining us today on this webinar on ensuring electrical safety and reliability, best maintenance practices for NFPA 70B standards compliance. This is brought to you in partnership with AEMC Instruments. Before we begin, I'd like to cover just a few housekeeping items. As you can see at the bottom of your screen are multiple application widgets. They're resizable and movable, so please move them around to get the most out of your desktop space. I'd like to also encourage you to submit any questions that you might have by using the Q&A widget, and we will try to answer as many as possible throughout the broadcast. However, if a full answer is needed or we perhaps run out of time, we'll make sure to send you an email after the webinar. I'd like to also draw your attention to the resource list that will contain a copy of today's slide deck, some interesting articles and resources, and please bookmark any links that you might find useful. To answer any common technical issues, I advise to use the help widget. And finally, a reminder to look out for an email in the next 2 hours with links to review today's session. At this point, I'd like to introduce you to our moderator and our host. We have with us Greg Wong, who is the Technical Product Trainer at AEMC Instruments. Very happy to have you on, Greg. I'm going to hand things over to you, and I hope you enjoyed the session.
Great, thanks, Kyle. Again, I'm Greg with AEMC Instruments, and today I'm joined with two resident experts on the subject of maintenance testing, not only for the compliance of NFPA 70B, but for best practices overall. AEMC Instruments is a manufacturer of electrical test and measurement devices that could be used to complete many of the tests that we're going to discuss today. And I'll be speaking on some of our instruments, as well as how you could find us at aemc.com later on in the presentation. I'd like to start by introducing our two speakers for today's presentation. First and foremost, let's introduce Tom Sandry. Tom is the Director of Workforce Development at Vector Power. Tom, tell us a little bit about your experience and what you bring to this conversation.
Oh, thank you, Greg. As you mentioned, I'm currently the Director of Workforce Development at Vector Power, and we are an electrical test and maintenance company. I've been in the electrical industry, I always hate saying this, about 38 odd years, from the northeast of the U.S., Pennsylvania. So based on my time in the industry, I guess you can say I studied under Ben Franklin at Philadelphia Electric. But been involved with the utility, and then midway through my career switched over to the commercial industrial side of electrical, and that's where really my familiarization with the NFPA code standards and best practices really came to fruition.
Great, yes, and you're one of the best resources out there for understanding the subjects around electrical test and measurement on your YouTube channel as well, too. So we'll make sure to plug that later on before we get off today.
I was going to say, thank you for that shameless plug for my YouTube.
Yes, of course. Also joined by Ahmed Gamil from Hitachi Energy. Ahmed, tell us a little bit about your experience and how you're going to, or what you can add to today's conversation around electrical test and measurement.
Thank you, Greg. Good morning or good afternoon, everyone. Depends on your time zone. Actually, I'm a specialist mainly on power transformer technology. For the moment, I'm taking care of the development of this as a product and also in interconnection with the grid or by Hitachi Energy. As is maybe shortly about Hitachi. Hitachi is a Japanese company, and when you hear Hitachi Energy, that means this is Hitachi in Europe. So my location is in Germany, and my focus, as I said, is related to power transformer technology, not just as a development in a product, but also to secure safety and maintenance of that product to avoid any blackout in some regions where the transformer is located, and also at the same time to ensure the expected lifetime of the product without any issue of interrupt.
Great.
So hopefully I will be good contribution giving here. Thank you.
I'm sure it will. Thanks, Ahmed, for that introduction. And for our audience, we're going to ask a few poll questions and give you a few short seconds to answer those poll questions. So let's get started with one. Have you reviewed the updates to, oops, sorry about that. Have you reviewed the updates to NFPA 70B standards? Yes, thoroughly, briefly, or not yet? If you're familiar with NFPA 70B or have any understanding of what those changes are, which of course we're about to discuss here, but we're interested to hear from you in the audience. So you just a few more seconds to answer this question. Great. So it looks like the majority of the audience has not familiar with NFPA 70B, and maybe not be familiar with some of the changes that have taken place pretty recently in the last calendar year, a little less than the calendar year here. So let's jump over to our first panel question. What are some of the key updates or changes in the most recent version of NFPA 70B that companies should be aware of? Tom, I'd like to kick this over to you. Let's start with what actually was the change here, and then let's talk about what the spirit and context of NFPA 70B is specifically.
Okay. If I seem to be turning my head and everything, I just have some notes and everything, so bear with me a little bit. The obvious is the 70E transition from recommended practices to a standard. So the biggest change that people who are familiar with 70B are going to find is that a lot of the verbiage has changed from you should be doing this and that, and is now, as a standard, changed to mandatory language, you shall be doing this or that. So that's the most obvious change that's affecting everybody. But within that, there are about 5 requirements now in the 2023 70B that all organizations really do need to be somewhat aware of. And a lot of these you may have found in the older versions, but they're more definitive, better laid out. For example, in Chapter 9, which is the maintenance intervals chapter, it now provides mandatory scopes of work and maintenance intervals broken out by product type and based on an equipment condition assessment. Second of that list of 5 is the equipment condition assessment is a very key aspect to the flow of the whole document. Maintenance intervals will be based on condition assessment, which depends on the equipment's physical condition, the criticality of the equipment, and the operating environment that the equipment is placed in. Third, the electrical maintenance programs are now very nicely defined. In Chapter 4, which is the general requirements, 4.2 describes the development and implementation of an electrical maintenance program. And it's broken out very, very nicely of what is expected in the program. Let's see, I think that brings me down now to item 4, field testing and test methods. The 70B now provides detailed prescriptive scope for preventative maintenance in Chapter 8, field testing and test methods. Now, compared to previous versions of the 70B, the update clearly defines testing category types in Section 8.3. So again, we're seeing a lot more definitive and a little bit easier, more descriptive flow to the language that's being provided. And finally, the 5th key element that all organizations should be aware of is system study intervals are now defined. So in alignment with the National Electric Code and with NFPA 70E, the safety standard, the new 2023 70B in Chapter 6 provides detailed requirements for system studies, including up-to-date single-line diagrams, short-circuit studies. Mandatory intervals for these studies shall not exceed 5 years, and that includes your short-circuit studies, coordination studies, and incident energy analysis studies. So those are some of the big high points that I think a lot of people are focusing on.
Great, thanks, Tom. I think it would be helpful for both of the guests here to maybe highlight a few items within an electrical system, apparatus, cables, that sort of thing that should be tested as part of this maintenance plan. And we'll touch on why that is as we move forward. But Tom and Ahmed, let's start with Ahmed first. What are a few examples of some apparatus in the general facility that may be tested as part of this plan, both offline and online, of course, too, so the audience is familiar with terminology?
Yes, actually, Tom has given a very good overview, actually, about the main interesting changes, which, if I just project it over the power transformer field, there are good introduction now about the possibility of making offline and online measurements. This was actually something like undefined for us. And especially if we're talking about safety and regular maintenance. And I noticed as well that this time the standards is really emphasizing clearly the importance of monitoring system. And this is a really key method and key instruments, which is still, I would say, there is a booming in the field, but the people are still so conservative, I would say, to rely on this. And stating this in such a standard like NFPA is really encouraging and pushing the people to see the fact that without regular observation, which you cannot making always manually, you are missing here a big advantage. I see it really important and amazing in the new standards.
Great. So, Tom, very quickly, what are a few, and we can't create an exhaustive list here today, but what are a few other apparatus? I mean, I know you as the king of cable testing, but what else should we be looking for to add to our maintenance program to make sure we're in compliance with 70B? What other things should be tested?
Probably, I'm going to say definitely up there in the top 3, your circuit breakers. Circuit breakers and relays are critical because, let's face it, they control the clearing of faults. So if the breakers are not up for the task, if they have not been lubricated properly, if they've not been exercised in 15 years, the chances of them not clearing in the time allotted, the likelihood goes up tremendously. That obviously leads to higher incident energy, arc flashes, which obviously safety to the equipment, safety to the personnel starts to become an issue. So if I had to settle for my top 3, making sure that your protection scheme is doing what you expect it to be doing in the manner you expect it to be doing it. So circuit breaker testing and your relays definitely rank up there very high.
Great. So let's ask the audience one more question, a few more poll questions as we go here. How often do you perform electrical testing and inspections to ensure ongoing compliance with either 70B or other standards that you may use, or a reliability maintenance program? How often are you doing online and offline testing at your facility? So we'll give you about another 10 or 15 seconds here to answer that question, and we'll review the results shortly. All right, so let's take a look at the results here. We've got annually, that's fantastic. the time period piece of 70B was probably one of the bigger points in which many of the formal training programs have been emphasizing. Incredibly important piece there is to add that periodic maintenance to your existing plan if it's not already there, or to bolster it, depending on what kind of maintenance strategies you use. So usually annually, 3 to 5 years are going to be those threshold. I'm glad we don't see any nevers on here. The run to failure concept is not a great way to operate your critical infrastructure in your facility. So for our panel, question number 2 here, importance of preventative maintenance. In your experience, how critical is preventative maintenance in reducing equipment failure to ensure safety? And maybe you can highlight some potential consequences or advantages really too, because we always think of safety as being the number one reason we're doing this test, and it absolutely is, but there are some other advantages to maintaining your electrical offline and online testing. So Ahmed, if you'll do us the pleasure of answering this question with some experience, we'd greatly appreciate it.
Yeah, for sure. Well, how critical is very critical if you are not doing this according to a certain plan. There is also one interesting indication in the standards, and what we're discussing today is the condition 1, 2, and 3. So this is actually mainly relying on how often you are making your inspection and maintenance, running your maintenance plan. And normally, whatever equipment it is, switchgear, transformer, cable, you know very well that at certain period of time, you need to have a plan B. So if you are going to get a signal that this part or this equipment must to be isolated from the system, then you have to have a backup immediately. Preventive maintenance is reducing this surprise to have a failure, and of course, ensuring safety from the power supply that you are ensuring it. And of course, also, if you take a look on the business, no utility will like to lose few days without supplying their customers. So if I may highlight here some common consequences is if I neglect this pro maintenance, is this exactly what I was talking about. If I take as an example again, a power transformer, which is not taking into account the preventive maintenance, you can imagine that getting out of transformer without any backup, that means complete city could be blackout, and the penalty in that case is not counted by days, but it's counted by hours.
Of course. So, facility downtime is a serious concern for those in the, production world who are in the manufacturing space. So we want to make sure that we're maintaining critical power supplies, having the backup where necessary, and being able to stay online as long as possible. Tom, in your experience, how critical is this maintenance? And I'm wondering if maybe you can cover some of the more nuanced subjects here of what it is that we're measuring specifically, and bring just quickly to light why it is we're going after those measurements to quantify the performance of our system.
Oh, very good. The obvious as far as the benefit, we control unscheduled downtime. And again, depending upon your business, the criticality of your business, an unscheduled outage could translate into very high dollar losses and so forth to production and so forth. So, that's the most obvious of why we're always concerned with maintenance. When we are looking at predictive maintenance, we are looking at testing to a time period, whatever that time period is defined as, annual, or as we go into the new 70B, based upon equipment condition, criticality, and environment, we see different time intervals being introduced to us. And keep in mind that maintenance covers everything from like visual inspections, lubrication as required, to the electrical tests, whether they're online or offline. Some of those electrical tests, for instance, offline, probably the king of which is your insulation-based tests. If we go back to, I think it was the IEEE Gold Guide, it attributed that insulation failures rank up amongst the absolute highest as far as contributing factors to equipment breaking down. So things as simple as insulation resistance testing, conductivity testings with micro ohm meters, to, again, more online like infrared studies and so forth, looking for loose hardware components, failing components, all fall into your maintenance programs. But what I also find exciting is with the intelligence of the test and measurement equipment today, we're really going into a lot of diagnostic-based testing. And that's transcending us from predictive maintenance scheduled to condition-based maintenance, where based on the trends of the data, we can now start making some informed decisions where I've got time for a plant outage this year. I've got X amount of equipment that needs to be tested. I've got Y amount of time to do it in. In a condition-based maintenance program, we can go ahead and take a look at the trends and make sure that during that outage, we're hitting the assets that absolutely are showing the trend that they need to be looked at, where the other ones where they're showing stable and consistent, okay, if we get to them, that's awesome, but we've got to get to these assets. And then, with some of these new online advancements, now we're also looking into the world of predictive maintenance, where we can start, don't get me wrong, predictive not saying it's going to tell us when it's going to fail. I think if anybody had that answer, well, we wouldn't be wasting time doing webinars. We'd be out in Hawaii someplace, kicking back and relaxing. But the predictive techniques allow us to now start managing budgets, managing inventories, scheduling maintenance instead of it, just falling on annual dates and so forth. And again, I think the technology is getting there where we are better informed today than we've ever been. So hopefully that met your criteria, Greg, of a little bit of examples and where we're moving as an industry.
Yep. Well, this kind of rolls into the next question here for the panel. So we'll kind of continue this into a little bit more depth here. What are some essential elements of an effective electrical maintenance program, and how can we implement one? I want to add something that Paul Gill wrote, Electrical Power Equipment Maintenance and Testing. I wouldn't suggest reading it straight through. It's about, I think, 700, 800 pages of electrical test and measurement. Wonderful reference, though. But in chapter 2, he highlights that even as advanced as our systems have gotten, no matter what type it is or what kind of system, the insulation and contact resistance testing portion of the offline maintenance is still the king here. So maybe you can give some explanation as to why that is, Tom, and what type of measurements we can implement to just get started with a good maintenance program, whether it be predictive, periodic, or otherwise.
Very good.
Yep.
The effective maintenance program. Probably a lot of people may find this part of 70B to be the most daunting starting out. And probably the most difficult part of it is getting started. If you don't already have a program and so forth in place, where maybe you're just making tweaks and adjustments to it in order to be in compliant with the new 70B. So for those that don't really have programs, getting started is always going to be the hardest part. But again, I compliment in chapter 4.2 of the 70B, it really does provide a very well-defined, what are the elements that make up the program? And there are several elements in there. But if we go into fundamental testing, what are some of the fundamental tests that we want to perform? Again, what we're going to find is things like insulation resistance testing. we're going to find things like continuity testing, winding resistance testing, for instance, like our transformers or our rotating machines, insulation testing on, well, pretty much any electrical apparatus. Name your poison, insulation testing falls into play there. But again, like if we're looking at specifically like on transformers, turns ratio testing, again, power factor, which is again just a form of insulation testing and diagnostics. And the equipment for getting started, I mean, some of this equipment is very straightforward, very easy to implement. And there's a lot of industry guides that will assist you in deciphering the results of the data. One thing I do want to point out, whether it's the NFPA 70B or other literature guides that are out there for test and measurement or maintenance, manufacturer specifications always take precedent. That always rules. In the event that you don't have the manufacturer specifications, 70B provides different recommendations as far as where measurements should fall into. Also, another phenomenal resource that's out there is the International Electrical Testing Association, or NETA, N-E-T-A. They publish what's called the acceptance testing standards and the maintenance testing standards. And in their literature, they're full of tables. So again, if I'm taking insulation resistance measurements, if I'm doing high potential testing, or many of you might be more familiar with the term high pot testing, I've gathered data. What does it mean? I can reference the NETA tables in lieu of not having manufacturer specifications at my disposal, and it will give me guidance as to, are these good, dubious, or do I need to be concerned with these readings? So again, there's a lot of industry support that is out there. The initial listing of equipment, well, again, one might be just visual inspection. Simple things like lubrication. If you're getting into the test and measurement, insulation resistance, conductivity measurements, and I know one that's near and dear to your heart, Greg. How good's your grounding system?
Ground systems, yes, yeah. We love
I
to
knew
talk
that would put a
about
smile on your
ground
face.
systems testing. Yeah, got a special place in my heart for sure. Well, Tom, that was great. A great introduction as to how we can go about taking a measurement and then determining whether it's to qualify, whether it's good or bad. Is this going to pass the muster against the codes, or as you mentioned, the manufacturer specification is critical. Get that phone call a lot, or in training, what's a good measurement? How do I know if it's good? What does the manufacturer say is always going to be the first answer. Ahmed, to turn to you, Tom touched on, what do we do with our results, right? Are they good or are they bad? I think, though, one of the most interesting areas that we can discuss and give a brief explanation on for the attendees today is trending data. How do we go about taking these values that we've established and periodically or on a condition-based trend those data points for longevity on our equipment and to make sure we're meeting the requirements? So any input there on how we can develop a good trending program?
The most important thing actually when you are treating data, that you have to taking it from one hand. That means there is a big deviation you can find between data and certain period of time just because you change your measurement equipment, or you change your lab, you change the personnel who is dealing with, and even sometimes it's changing even the shifts is making some change. So the most critical one is actually if you have a schedule to check the trend, that data trending, and you have to stick with it. And another point is the accuracy of the devices which you are using it for trending this data must be known and limited in a certain acceptable way, that you are not going to be confused at any change of the results you are observing over time.
Great. Yeah, I think one area that I would like to add there is of course training, discussing the small nuances. I like to refer to them as test hygiene. If I go out on a floor or I'm working in an environment that I can encounter contaminants, how do we go about, from a trending perspective, ensuring that the data that this technician collects is going to be taken with the same procedures and precautions that other technicians will take? So I think if I could add one thing to that piece, to ensuring good trending data, it's test hygiene, clean leads, what good setups, good timing, depending on what kind of testing we're doing, and ensuring that we're doing the small things to make sure we get the best results, because people add the most variance to a measurement. So let's jump over to our audience now and discuss what type of maintenance testing are you currently doing as part of your routine plan? Most everyone has become familiar or is somewhat familiar with a lot of the new online types of monitoring, which are fantastic for continually monitoring the condition of different types of electrical equipment. But are you familiar with the concepts behind insulation testing, one of the more misunderstood yet simple tests to complete for your fleet of electrical apparatus? Are you doing any type of vibration analysis, power quality analysis, or maybe even some environmental testing too? So let's take a look and see what the audience had to say about what kind of testing they're doing now. So it looks like many of the audience, 56%, most of you are familiar with the subjects around insulation testing for different various apparatus, a little bit of online vibration analysis, some ground resistance testing. Thank you for those of you who are completing this. This is a critical part of maintaining apparatus, especially that sensitive stuff you may have. Some power quality analysis and a little bit of environmental testing too. So looks like a pretty good mix here. The important stuff though, that insulation testing, critical to the longevity of your equipment, of course. First thing that's going to fail, one of the first things that's going to fail, I should say. So for the panel, what is the role here of test and maintenance instruments as part of an effective testing routine? Maybe you can discuss some of the latest electrical test and measurement tools that have been instrumental in enhancing the maintenance program process, and do regular inspections and testing, improve system performance and reduce shutdown. We've kind of touched on that here, but Tom, you're the maintenance test set guru for this webinar. So what are the test what are the measurement tools that we should be requiring, or what are recommended to meet the requirements for NFPA 70B? And what should the general staff at a facility have in their tool room?
Again, I'm going to start with the most basic tools, the ones that pretty much any test and measurement technician is, the first things that are ever handed to them when they become a certified or qualified technician. An insulation resistance tester, okay? And again, depending upon what you're maintaining, it can be anywhere from the 1 kV variety up to the 5, 10, or 15 kV variety of insulation resistance testers. A micro ohm meter, again, continuity measurements, whether it's literally testing torque values, because again, being torqued and being tight does not mean you have a good electrical connection. So even as simple as micro ohm meters for just continuity tests and electrical connections. Then going into, again, like high potential test equipment. Your high potential equipment, insulation resistance test sets basically give you the insulation resistance of the systems. Your high potential test sets show you what your dielectric strength is. It's an overvoltage test to show what your overall dielectric strength is. Now, here's one area where I'm very, very excited in the way the industry's transformed. In the past, when we did high potential testing, we would set a pre-described test voltage to the apparatus, and we would run that voltage for a prescribed period of time. When the timer went off, ding, 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 if the system did not flash over and fail, we patted ourselves on the back. We congratulated ourselves on being very good technicians, and we went home for the day. But it always raised the question, what if I left the voltage on there for 1 more minute? What if I left it on for 5 more minutes? Or what about next week? One of the advancements that I'm absolutely thrilled with is this new concept of monitored withstand testing, where a lot of the units that are coming out, built into the units, you have a dissipation factor or tan delta bridge unit built into. Now, for those of you that are unfamiliar, power factor, dissipation factor, tan delta is what I kind of affectionately just called loss angle testing. And it's a AC form of insulation testing, integrity. What's nice now is incorporating that as part of your monitoring technique. You hook up your high potential test set. Let's say we're going to run a 30-minute test, just pulling a number, okay? Instead of just being reliant on the timer or trying to diagnose the leakage current values, I can actually look at the loss angle. If the voltage is not changing, but I'm starting to show instability in the loss angle or a rise or change in the loss angle, it tells me that I've invoked ionization and possible partial discharge activity, excessive leakage, and now I have the opportunity to immediately shut down before allowing it to go to fault. So I can now have dialogue with my superiors and say, hey, this is what we found. If we need to re-energize, I've left the circuit in as close to as found as possible. I did not grow the defect any further. I was enlightened that there is something going on there. I stopped immediately. If we do proceed, our course of action really now is to run to failure and then locate the defect, repair, and put the device back into service in a more reliable state. So I find that exciting. We're out of the dark ages of high pot testing. We're into the intelligent world of high pot testing.
Great, thanks for that, Tom. And I'll add for the audience, if that was, you feel like that was above your head or if you have questions, both Tom and I are in the training space, so feel free to reach out to discuss training being critical to understanding the operation of these test and measurement devices. So over to you, Ahmed. Are there any electrical test and maintenance tools that you would recommend a general facility to own or rent for the purposes of completing testing to meet the NFPA 70B criteria?
Actually, Tom picked a very interesting and famous point in industry when we have a lot of standards measurements which is taking 1 minute or 1 hour. So what about if I keep it another few minutes more? Right. I would say very interesting and important measurement tool is the measurement PD measurements, partial discharge measurements, and this is exactly the same example like Tom explained. We have in IEC standards, and I think in other standards as well, that maximum, I would say, within 1 hour you finish the test at different level of voltages. But the experience was showing actually that this is one of the most important tool to implement on site, that at any time, any indication showing that I have an overexcitation of the PD level, then I have to shut down before a fault is happening. Another one actually, which has been introduced lately, but we are getting some requirements from customers and utility to put some limits for vibration tests. So let me give the transformer as an example. Once you have a certain limit of the vibration, if this vibration is increasing, that means you have any mechanical issue inside, That means overheating could also release this because of any thermal expansion to the metal from inside or outside. So I would say these are very important tools which should be always there on. And it's also interesting thing in these two measurements is that they react so fast. So I will have a direct indication if I have taken action, switch off my instrument, or taken any actions to prevent any failure.
Great, thanks, Ahmed. So let's quickly cover what AEMC can help you with as part of your test and measurement solutions at your facility, whether you are a testing technician or you're looking to get into making sure that you can perform your own test and maintenance programs at your facility. So first off, thermography is going to be a huge one, right? This is an online test, completely hands-off, very safe to perform, especially when IR windows are installed, and completely non-contact as well too. We can detect phase imbalances, we can detect high resistance where it shouldn't be. We can also see insulation breakdowns and failures as well too. So critically important here for rotating machines and things that should be moving, switchgear, breakers, and so on. Our contact resistance test instruments, also known as micro-ohmmeters, DLROs, or as affectionately known as the ductor, for testing low resistance connections on breakers, different parts of the conductors, really anything that has a joint or makes a connection that is going to conduct an electrical charge. Heat is the enemy, right? Anywhere that we can incur high amounts of resistance is going to build up and create heat, of course, right? And this can be one of those indicators that we could have a potential failure on our hands in the future. So ensuring that we have a low resistance connection ensures that we are not going to have a failure in the future. And this could be on a grounding system, this could be on something that is current carrying as well too. And then as we've mentioned before, insulation resistance testing, our 5050 is a 5 kV megometer, which means that we can apply up to 5 kilovolts of test energy into the subject that is under test, as well as a 6526, more of an insulation test multimeter. Get a lot of different functionality out of this. Great for those of you who are doing any type of rotating machine testing, like low voltage motors, low voltage here being 480 and below, of course, on our rotating equipment. So if you are interested in learning more about AEMC's electrical test and measurement devices, you can scan one of these QR codes. A few other things here. We've got our power quality analyzers. These are great for online test and maintenance. We have both power logging and power quality analyzers as well too. So if we're trying to hunt down a specific issue or perform something just like a simple load study, maybe we're going to add on to a facility, we can perform that with one of these devices. Our PEL 103 power energy logger definitely being one of our better selling instruments, as well as one of the easiest loggers on the market. I can't stress that enough. It's an incredibly simple instrument to operate. Motor testing specifically, covered that a little bit already, but we've got megometers here in this list as well too, and some phase rotation instruments to be able to verify that we've made our connections properly and our motors aren't going to spin backwards or have other issues potentially. Transformer testing as well. We've highlighted some very basics on the transformer side of things. Ratiometer here, AEMC manufacturers one of the best single phase ratiometers out there, mainly because it's so simple to operate. So we can determine the ratio of a transformer. Incredibly important when we're receiving that transformer before we energize it, and then periodically as a maintenance test to make sure that the transformer is in good operational condition. We've got our online test with our thermography as well, and then insulation resistance testing. You've heard us say insulation resistance testing a lot today. It's just because that is one of the most critical elements. It probably is the critical element to an electrical system. No matter the voltage, the size of it, where it's located, it's going to have some type of insulation that could potentially fail. Also, understanding how these instruments operate is critical to making sure you produce valid measurements. Please reach out to us to discuss that more if you have questions on it as well too. Last here, just a couple more. Sorry, we've got our environmental tests and data loggers. Here we can collect different environmental qualities and log them, being the strong point of these instruments here. And then my favorite is going to be ground resistance testing, but I am a little partial here. This is the test I enjoy the most. First off, you get to be outside most of the time when you're doing it. Secondly, it's a little bit more of a black or dark art, if you will, oftentimes considered black magic to those who are learning ground resistance testing. Testing the relationship of a ground electrode or a system of electrodes to the connection to Earth. So we quantify that with a resistance value. Requires a completely different set of skills than other resistance tests. So please reach out if we can be of help on these tests. So kind of bringing this towards the conclusion of the webinar here, we've got some really great questions from the audience that I'd like to tackle too. But let's both of our experts here are going to round this out for us. What are some of the biggest challenges companies face when trying to adhere to preventative maintenance standards? Because this is a test that really, it won't pay dividends in the immediate, right? It's only going to cost us. The long-term benefits, though, are absolutely there. But what are some challenges that we're going to run into, Ahmed, when we start to get into the subjects of test and maintenance? What skills do we need to make sure that we have? What equipment? We've already mentioned some of these things, but what else? What other challenges can we overcome or help our audience overcome to start a maintenance program?
Well, it's really good word to say that the biggest challenge company faces is actually when there is an indicator by testing or maintenance program, which is giving a slight risk or indication of a risk. I would say the biggest challenge here is taking a decision, because it could be really surprising that the companies could be in a moment confused a little bit. Should I take this action? Should I shut it down? And I think taking a decision and trusting your data, this is the biggest challenge all companies are facing. If these two are not available and really trained people who are in a position to take this action, this could be resulting in a big lose of the equipment performance as well. So if I going out to just given in short example, I still remember it. Maybe some of our audience also hear about the technology of using the health index of the product, and this health index is actually nothing more than a number. It's telling you that your equipment is in a performance of, instead of 100%, is 70% or going down to 30%. So behind this, there are algorithms which must be made actually by the people who are professional in that. They know what they are doing. They know what kind of product they are dealing with. And I still remember an example that I would say one of the very good algorithms from some companies which I know previously, they were showing that one of the transformers should be shut down, and the utility was never seeing anything else from outside over decades. But they trusted the people, they trusted their experience, and they decide to shut down the transformer, and it was completely black, something which was not easy to detect from outside by very simple measurements or regular measurements from the liquid. So yeah, this this is something which must be embedded inside the company, and they have to be trained to be able to be
Sure.
brave to take such decisions. Yeah.
Sure. Tom, I wondered if you could share a real world example of a company or an organization that has maybe implemented a successful maintenance program. And of course, when we never know if maintenance is successful, other than knowing that no news is good news, right? So, any examples of how an organization has implemented a successful training program, or excuse me, a successful test program?
Oh, absolutely. Really not sure. I'm not going to mention their name just because, you know, I haven't cleared with them to use their name or anything. But there is a rather famous company in the food processing world that I remember when I first was introduced to them. They were just getting started with really building a robust test and measurement program, and their unscheduled outages were starting to get the better of them, which again was one of the driving factors toward moving toward this type of a program. Because an unscheduled maintenance or a fault, you've got equipment damage, depending on lead times and so forth, prolonged periods of time that, systems are down and so forth. So the most difficult, or the challenge, was obviously addressing this, getting started with what are the elements that goes into a robust system. Okay. So that was obviously one of the big challenges that they had to face. Now, again, had the 70B been written in the fashion that it is now, probably would have helped accelerate or give them better guidance on what they needed to do. But, they persevered, they stepped up, they built a very good maintenance program. The second big challenge was any maintenance program needs to be conducted by qualified workers.
Yes.
I can go ahead and I can get access to an insulation resistance test set. I can connect it across something. I mean, the instruction manuals are pretty clear on how to hook it up, and I hit that test button and a number appears to me. What does it mean? What do I do with that number? What action should I take or not take based on that number? So the other big challenge was obviously getting training. As you had mentioned a couple times, training is very, very important. And part of that training is not just, training on the test set, learning how to push the buttons. That's what you manufacturers do a gorgeous job with your instruction manual. That teaches me how to push the buttons.
Yeah.
I need to be trained on what to do with the results. And part of that, sometimes it means I might have to brush up on my fundamentals of electricity knowledge. What is this data telling me? So the outcome of going through these challenges and staying true to it, seeing it through, obviously now they have relatively robust systems, very few surprises of unscheduled maintenance outages and everything. They're doing predictive, but in other areas they're doing they're doing the preventative, but in other areas they are doing the predictive maintenance, looking at the trends, making smart decisions. And yes, there was some up costs, in the training and the time and effort to build the program. But now they're reaping those benefits, because there's nothing more costly than the unscheduled outage.
Yes. Yeah.
So eliminating that aspect, and taking control of your destiny and start making smart decisions as it affects your plant, your infrastructure, there's where you see the benefits. Maximizing on production, uptime, and obviously your profits.
Right. Great. So what I'd like to add here is to just keep in mind, no matter what kind of facility you're in, there are electrical test and maintenance professionals available to come help you with a program, to structure part of your program to where it's a hybrid approach, that maybe you handle some of the testing and they're going to handle everything else. Oftentimes, in my experience, when we approach an MCC, this is going to be some motor control center. This is going to be something that the maintenance company handles, like Vector Power, who Tom is a part of. So keep in mind that you can always look to NETA, the National Electrical Testing Association, or TAG, or other organizations to help you structure a maintenance program. And they're fantastic companies to work with to help you get started in electrical test and maintenance. Also, too, the manufacturers of your test instruments offer training. A little biased on that one because that's my job with AEMC, but we're here to help as well, too, to make sure that you're using those test instruments well. And you know how to take the information and interpret the results. I'm big on talking about interpreting results because instruments don't lie, but they can produce data that may not meet the requirements or may not be what you expect. And why is that? So we discuss all that and more in training. Last, I'll add that organizations like the SMRP, Society for Maintenance Reliability Professionals, are doing a fantastic job of structuring maintenance programs and doing education on how to go about taking your facility and putting it into silos as far as different maintenance standards or practices you may take on. So I want to make sure that we leave some time here for the question and answer section from our audience here, because there's been a lot of really good specific questions here. Quickly, somebody asked, what ground test methods would you recommend for like a lightning rod installation where there's no physical earth or soil near the ground rod site? That's a little hard question to ask or answer specifically, but the asker has mentioned the clamp-on meter. That may be the best application for that one. So I wanted to tackle that one really quick. And then also, I think a really interesting question that was asked here, a subject that I'm very fascinated by, is like, what about online oil analysis in transformers or other oil-filled apparatus that may be out there? And I think we've got some really good expertise in this area. So what's growing in online DGA right now, or just DGA in general?
Well, there is most of the monitoring systems and companies who are offering the online DGA is actually well trained. They have a lot of experience based on that. The only issue is that until now, there is no standards working on that. So to analyze that, there is a lot of limitation known previously from experience using offline measurements. So like you take a sample from the transformer oil and then you make the analysis, you know the results, you know what kind of action you need to take. However, because of that big competition and booming in this field, you will find and until now, there is no clear guidance in the standards. And if I'm talking here about IEC standards, to set a rule how to identify and make the analysis of the results coming from monitoring system, online monitoring system for DGA as an example. Because most cases, the companies are working on, from their point of view, critical gases, and they forgot about the rest, while the whole experience needs the whole picture of the DGA. And this is the open gap until now, I would say, in this field.
Yeah, DGA being dissolved gas analysis, for those of you not familiar, super interesting subject on being able to do a little bit more predictive maintenance or prediction about the life cycle of oil-filled apparatus like transformers, for instance. Really important question for you, Tom. You stated at the beginning that circuit breakers were one of those 3 critical items for testing. Maybe you could mention what the other 2 are, and if you could put those in a specific order of operation, if there is one.
Well, definitely I always first go to my protection scheme. So the protective relays and the circuit breakers make up a large component. They're not operating properly, and we don't clear faults in a timely manner. It could lead to devastation to a transformer, which is probably one of the most expensive items we own. So definitely relays, circuit breakers, and all right, I'm going to go into one of my favorite subjects, the interconnecting cabling and bus structures. You're only as good as your weakest links. So again, failures at cable terminations, splices, and so forth. Again, we don't think about that little 100-foot stub of cable connecting two critical devices together. But again, their performance is only as good as the weak link. So there's my pick for the top three.
I always describe it as removing series resistors out of a circuit. You know, if we want to enhance the performance, ensure that our electrical apparatus, cabling, interconnections, whatever it may be, are operating effectively and efficiently too, because there's a bit of an energy savings piece there. Lowering that resistance or ensuring that the resistance meets our specifications is key and critical, and a fairly simple measurement to quantify as well too, when we talk about the measurement procedures there. So let's wrap up with a question about the kind of the enforceability of 70B and bring it back to some of the policy here around 70B and this change. And I would be remiss if I did not mention the triangle that you taught me earlier this year, the electrical safety triangle of the different codes here. So if you could maybe speak really briefly on that, and then how will we see, what is the future here of 70B and other standards around electrical maintenance and testing? What's driving that too?
Okay. I'll jump in on that for as far as enforcement and overall goes. First and foremost, let's deal with who enforces it, okay? Because one thing that we do need to keep in mind is OSHA does not directly enforce NFPA standards, okay? They do not directly enforce. However, they can use this NFPA standards like 70E or 70B to issue violations, okay? As far as enforcement, I'll probably go to the 70B is a document that the authority having jurisdiction can use to enforce key maintenance requirements affecting safety. Now, you might say, okay, well, who's the AHJ? Well, an organization, office, individual responsible for enforcing requirements of a code or standard, or for approving equipment, materials, and installation or a procedure. Now, that can be like in the public area. It could be federal, state, local, or other regional departments, individuals like a fire chief, fire marshal, chief of fire prevention bureau, labor department, health department. For insurance purposes, it could be insurance inspection department, rating bureau, or other insurance company representative. But in many circumstances, the property owner or his or her designated agent assumes the role of AHJ. At a government installation, the commanding officer or departmental official may also be the AHJ. So it's really kind of with the AHJ to be the enforcer on this. And 70B now being a standard kind of empowers them to do that. Going back to what you were saying as far as the Trinity.
The triangle. Yeah, the triangle, yeah.
What I really love what we see have happening here is we have codes and standards. Codes can be adopted into law. So starting with that, we have the National Electric Code, NFPA 70. That is a code that many states have adopted into law. Okay, so it defines how we are to build safe, robust, reliable systems. Now, 70B is this gorgeous complement to it. And now that it has become a standard, aspects of it can also be adopted into law and recognized in through the NEC. So basically, it's great to have a robust system, but if you don't maintain it, it's not going to be a robust system very much longer type concept. And then we've got the third corner of this beautiful triangle, the NFPA 70E, electrical safety. So 70, how do I build it? Safe, reliable, robust. B, how do I maintain it? And E, how do I keep the worker safe when around it and working on it? So they all interact with one another. 70E basically says the likelihood of things becoming more dangerous is when you don't maintain. 70B, how to maintain. You can kind of see how they just all interrelate with one another now.
Yep. Yeah, that was a great answer. Someone asked, what does AHJ stand for while you're answering that question? And that's, of course, authority.
Yeah, authority having jurisdiction.
Yep.
Yeah.
And depending on what kind of project you're on, that's your best friend or could send shivers down your spine. And hopefully it's a great working relationship. And that can mean a few different things too, I should add here. I know we're a little over time and we'll be wrapping up shortly, but an AHJ isn't necessarily just a government individual, right? Somebody that is, out there enforcing some code. An AHJ could also be somebody that's assigned to the worksite for the company, for instance. So
exactly, it could be somebody that you appoint. It could be your insurance provider.
Right. Ahmed, any last comments before we jump off the phone here, or jump off the call here?
Well, yeah, just hopefully that me and Tom today could give you a guide of highlights that will encourage you to take care of your employees, take care of your team, and extend the lifetime of your equipment as much as you could.
Yep. Great. Tom, anything you'd like to add here at the end?
Well, again, just really want to thank you for allowing me to be part of this forum. You know me, Greg. This is a subject that I'm very passionate about. I enjoy. I love test and measurement. As like you, I have a passion toward training and making sure that people out there are the best that they can be. So I thank you for allowing me to be part of this.
Well, a big thanks to both of you for joining us today for a conversation on the subject of electrical test and maintenance and compliance with NFPA 70B standards. Again, my name is Greg with AEMC Instruments. AEMC can be a partner for your test and measurement needs on the resistance testing side of things, whether it be ground, contact, or your insulation testing needs. As well as your power quality, power quantity logging, and other test and measurement tools. So check us out at aemc.com and reach out to us if you have any other questions. If we didn't get to your question on the question and answer, we will be sure to reach out to you directly following up after the webinar. So Kyle, I'll kick it back over to you. And thanks for allowing us to jump on and use your service today. It was a great webinar as always.
Of course. Just want to say a special thank you to our amazing panelists for your great insights and being so generous with your time today. On behalf of myself and Marcus Evans, we'd just like to thank you all so much for the collaboration. Just like to once again just say thank you to all the questions and comments that came through. If we weren't able to address all of them, the AEMC team will reach out to you after the broadcast. A reminder to look out for an email within the next 2 hours with links to review today's material, and we'd love to hear your feedback about what you thought about the webinar. A brief survey will pop up on your screen in just a moment. We would really appreciate any comments that you might have. On behalf of AEMC Instruments and Marcus Evans, we'd like to thank you so much for joining us and hope to see you again at future events. Thank you, everyone, and have a wonderful day further. Bye-bye.
Thank you.
Thank
Thank you. Bye-bye.